Chemistry paper 1, energy changes, the energy changes of reactions. For this topic you need some key vocabulary. Endothermic being one word. An endothermic reaction is one that takes in energy from the surroundings. So the temperature of the surroundings decrease. There are often misconceptions surrounding these words, so please be careful. We've been looking at this topic since year 7. However, the focus in 10 and 11 has been on energy profile graphs and bond energy calculations. Another word is exothermic. Exothermic reactions transfer energy to the surroundings. Remember, exo meaning outer. Here's a question for bond energy calculations. A lot of information given. So we've got the formula equation and we have got the bond energy for each bond. However, we've got to calculate the bond energy for X. Another point to note is this. 56 kJ per mole will be released in this reaction. So let's take a look at the equation. First thing to do is to count the number of bonds. Okay, we'll start with the breaking side first. So let's split this into two sides. Breaking and making. So on the breaking side, let's look at the HC. We've got 1, 2, 3, 4 HC. So 4 times HC. What else have we got? We have got the double bond, that's the unknown. And we've also got a HCl. Do the same on the other side. HC, 1, 2, 3, 4, and 5. What else have we got? We've got the single HC in the middle. And finally, we have got the CCl, one of those. This can now be used to calculate the bond energy on both sides of the equation. So let's do that. So now let's use the data that we've been provided. So we had 4 times HC on this side, on the breaking side. 413. We had the unknown, but we also had 1 times the HCl. Those two together. But remember that is 2083 plus the double C, which is the unknown. That's our breaking. Let's have a look at our making. On this side, we had 5 times the HC after counting. So that's 5 times 413. That is equal to 2065 after using my calculator. And then we also had 1 times the CC, that's 346. And we also had 1 times the 339. So the making altogether added up is 2750. Okay, we now need to put these two together to calculate what the unknown C double bond C is. So we now put the data into this equation. Energy released equals bonds made minus bonds broken. The energy released, according to the question, was 56 kg per mole. Bonds made were 2,750, and we need to subtract the bonds broken from that. That is 2,083 plus the unknown. This gives us 56 equals 667 minus the unknown, and if we finally subtract the 56 from the 667, that will give us the double C bond, which is 611 kg per mole. If we take a look at the GCSE mark scheme, here's the information provided. So mark given for calculating the bonds broken, mark given for calculating the bonds made, then putting them into the equation to calculate energy released, and then finally for calculating what the double C bond was. So a 4-mark question. How did you do if you were to do that yourself? Well, let's do a bit more practice. Here's another energy bond calculation. Why don't you pause and have a go? Again, I will go through this question and provide a breakdown. So the first thing to do would be to remember to identify and count the number of bonds. If we look at this, we've got this number in front. That tells you that it's 2 lots of everything that we've got here. So this would be 2 lots of HS, HS. So that's 4 lots of those bonds. So that would be 4 times HS. Could you do the rest? So let's just go through this. Breaking, we've got 4 times HS, 3 times the double O. On this side, we've got 2 times 2 lots of HO and 2 times 2 lots of S double bond O. Now we've got to use the data provided in the table to calculate the breaking and making. So let's look at the breaking first. We had 4 lots of the HS, so that would be 4 times 3, 6, 4. And we had 3 times the double O, so that would be 3 times the 498. Put them into your calculator, that would have given you 1456. This would have given you 1482, altogether 2950. For the making side, it informed us in the question that 1034 more kilojoules of energy were made compared to breaking. So therefore means that we have the 2950 plus the 1034. So that means that 3,984 joules of energy were made. So what does that leave us with the calculation? Let's solve it. So let's find the unknown. Remember, the unknown we're looking for is the S double bond O, and there were 4 lots of them. So we could refer to that as 4 times S double bond O, or 4x. I'm going to refer to it as 4x. So putting the data into a calculation, 4x plus the 4 lots of known HO bonds will equal 3,984. 4x will therefore equal 3984 minus 1856 from the HO bonds that we calculated. 4x will therefore equal 2,128. However, we just want x alone. So I'm going to divide this side of the equation by 4, and whatever I do to one side of the equation, I will do to the other. So x is going to be 2,128 divided by 4, and x will therefore give me 532 kilojoules per mole. How did you do? Have a look at the mark scheme. There we go. So again, marks given for bonds broken, marks given for bonds made. Marks given for putting those bits of information into the equation and then rearranging to find 4x. And then finally, marks given to find x alone. A tough 5-mark question there. Do you want a bit more practice? So do you need a bit more practice?
What?
Here's another question to have a go at. Remember small steps, counting the number of bonds, calculating them, and then solving what x is. Pause the video, have a go. This is a 5-mark question, and then check against the mark scheme. How did you do? Remember, marks for bonds broken, marks for bonds made. Putting them into a calculation, in this case finding 2x, and then finding x alone.